This is section 12.2, talking about problem solving with right triangles using our sine, cosine, and tangent functions. So it says find the height of the tree. Here we are, we're 1.5 meters tall. We're 60 meters from a tree and we want to know the height. We see that our angle of elevation, and we're going to talk more about what an angle of elevation is 24 degrees. So the height, or the angle of degree that you look up from your eye, from the horizontal. So if this is 24 degrees, we know this is 60 meters, and here's the height of a right triangle. So we now we can use one of our trig functions if we have one angle and one side and we're missing a side. Let's just call that x. So if we have, let's label, what do we have? An angle, we have the opposite side, and we have the adjacent side. So that means we would use, if we have SOHCAHTOA, which trig function has the opposite and the adjacent? That would be tangent. So we're going to say the tangent of 24 degrees is going to equal opposite x over 60. So then we can go ahead and solve, multiply both sides by 60. And we can say, so 60 times the tangent of 24, and that equals 26.71. So this height is 26.71 meters. And then we have to add this height, which is obviously not trying to scale. This height is 1.5 meters. So that will leave us with 28.21 meters. So this is pretty cool. People have been asking, how in the world why would we ever need to use this? But people use a lot of trigonometry to actually solve for heights that they can't measure. We talked about indirect measurement last chapter. So just as a heads up, if you are watching this and you're missing class, this coming week, we have 2 weeks left. Check your grades. I handed out a homework printout. Check what homework is missing. Are you missing a test, a quiz, etc.? Because you can still turn that in. You can come in Tuesday and Thursday morning this week, and we can work on that material. And then, so today is Tuesday. Wednesday, if it's nice out, we're going to go outside and use what we call clinometers, which I will explain more in the lesson. And we're going to actually find the height of objects that we can't reach using angles and one side length of a triangle. If it's not nice, because it's supposed to rain all week, we're going to take a team quiz, and then we'll review Thursday, and we'll take a test on Friday. And then we'll make sure to go outside the next week to do the clinometer activity. So just as inspiration, to make sure that you're actually remembering, we have 2 weeks left, finish strong. This is a short video of Haile Gebrselassie, and he is like a world record holder and a very fast distance runner, but these are a couple clips of him finishing his races and actually setting world records, so I thought you might be inspired. He's right here in the green. This is the end of his race, so the last 100 meters, right here, this is him. And here's the last lap of another race. Okay, well, if that doesn't get you excited, I don't know what does. So, my hope for you is that you really do finish strong in these next 2 weeks. So make sure you get these quizzes and tests taken care of. Come in the morning. The sub can pause the video, and you guys can check your work. This was the worksheet for 12.1 day 3. Here are the answers. So here's one page, and here's the other page. Okay, now we get to start our lesson. Today we are just solving word problems using sine, cosine, and tangent, and inverse sine, inverse cosine, and inverse tangent, where we're trying to find a missing angle. So, just as a review, we talked about this on Friday, but we're going to talk about it again. The angle of elevation is the angle by which you have to look up. We're going to just write this really informally. It's really the angle above the horizontal. So we're just going to say the angle that you have to look up. To look up. So if I'm trying to look at this object, I have to literally look up at the object, so this is an angle of elevation. If I'm looking at this object, I have to look down from the horizontal, or from my eyeball, so it's called the angle of depression. So this is going to be angle to look down. Here's another example. If I'm at the ship, or I'm at the airplane, sorry, I'm trying to look at the ship. So that means here's my horizontal, and I'm looking down. So it's going to be an angle of depression. If I'm the ship, here's my horizontal. It has to look up at the plane, so it's going to be an angle of elevation. So now, in a couple problems, we'll have to actually solve for that. So now they say, in this problem, we need to find the area of this triangle. Remember, area of a triangle is the base times the height divided by 2. So the height is that altitude. Remember the perpendicular from the vertex? So here is, that's a terrible line. Here is my altitude. The nice thing is, if I have an isosceles triangle, remember 2 sides that are the same, I know my altitude is also the bisector of the opposite side. And it's the angle bisector. So these are also divided in half. So this is going to be 25 degrees. This will be 25 degrees. This side will be 1 centimeter, and this is also 1 centimeter. So if I want to actually find the height of this triangle, I can use my trigonometry using a right triangle. Remember, you need your right triangle to talk about those ratios of opposite side and hypotenuse, adjacent side and hypotenuse, and opposite side and adjacent side. So I have the angle 25. I mark my angle. I see that I have the opposite side, and I want to find this height, which is going to be the adjacent side. The height is adjacent. So I'm going to say, well, the tangent of 25 degrees is going to equal opposite, which is 1, over the adjacent. Let's just call it h, since we're trying to find the height. So to solve, we talked about a shortcut. I'll show you the longer way. I'm going to multiply both sides by h. And then I want to solve for h, so I have h times the tangent of 25. I want to get h alone, so I'm going to end up dividing by the tangent of 25. So h is going to equal 1 divided by the tangent of 25, which is approximately 2.14. So now I know the height is 2.14, so I can find the area is going to be base 2 times the height, 2.14, all divided by 2, which ends up being 2.14, because look, those 2's cancel. So about 2.14 square centimeters. All right, now they want us to find the height of A. So we know if we have a parallelogram, we know our opposite angles are congruent, and then we know consecutive angles add up to 180 degrees. So this angle must be, or we don't even need to worry, well, this angle would end up being 88 degrees, or 98 degrees, but I'm lying, 108 degrees, but we know this is 72, so we don't even have to worry about that. So here, this is 72. We're going to write this a little more clear. Okay, now if we want to find the height, I've got a right triangle right here. So I could say, well, here's my angle. I'm going to mark my angle, 72 degrees. The values, I'm trying to solve for A, which is the opposite side, and the hypotenuse is 8. So I can say, oh, well, sine SOHCAHTOA, sine is the value that uses the opposite side, the ratio of the opposite side and the hypotenuse. So I can say the sine of 72 is going to equal A over 8. Then I can go ahead and just solve. I can multiply both sides by 8. So I'd get A equals 8 times the sine of 72, which is going to be 7.61 inches, which seems very reasonable because the hypotenuse is always longest. Next, it says PS and PT are tangents. If they give that information, we know it's important. That reminds us that the tangent line forms a 90-degree angle with the radius. So we now have a right triangle. We can also say, here's another right triangle. If this forms a 90, here's the point of tangent CT. So this is also a 90-degree triangle. We also learned that if we have two tangents from the same point, they are equidistant. So this is also going to be 22 centimeters. So I'm just going to look at this triangle. We want to find the diameter. Oops. Here's this triangle. Remember, diameter is 2 times the radius. So which segment am I going to need? And we're going to actually need this segment from S to the center, or we could find this segment T to the center, but we're just going to focus on this right triangle. Remember, you need a right triangle. So I'm going to mark my angle because I have one angle and a side. I can solve for the missing side. So 22, that's my opposite side, and S to the center, that's my adjacent side. So opposite and adjacent, that's tangent. So tangent of 65 is going to equal opposite 22 over A. Then I can solve. I can use my shortcut. Really, I know that A is going to be 22 divided by the tangent of 65. If I type that into my calculator, I'm going to get 10.26. So this is equal to 10.26. Is that my diameter? Nope, it's the radius. So radius is 10.26. So the diameter is 2 times 10.26, which is going to end up being 20.52 centimeters. So the key to these problems is really just mark everything that you know, find your right triangle, and then mark your angle and figure out which is the appropriate trig function to use to solve for the missing side. Now we've got a word problem. It says a ladder 7 meters long stands on level ground and makes a 73-degree angle with the ground. So 73-degree angle with the ground. Here's my ground. And the ladder makes a 73-degree angle. So I'm going to eyeball this, but we're going to say it's about this. Okay, and it says, how far from the wall is the base of the ladder? So we know this is 7 meters long, our ladder. There's our ladder. How far from the wall is the base of the ladder? So we need a wall. The ladder is leaning against the wall. We've got a right angle. Walls are generally perpendicular to the ground. And it says, so that means how far from the wall is the base of the ladder? That means this length right here. We want to find this length. Let's call that X. And we know this is 73 degrees. So now I set up my picture. I drew my right triangle. I've got an angle and one side. So that means I can then solve for a missing side. Which trig function am I going to use? If I have the X is the adjacent side, 7 is the hypotenuse. If I think of SOHCAHTOA, Adjacent and hypotenuse, that's going to be cosine. So cosine of 73 degrees is going to equal x over 7. I can solve, multiply both sides by 7, and I will get x is going to be 2.05 meters equals x. And that seems pretty reasonable. If my ladder is going to be that steep, there's not going to be that much distance between the house and the wall. So this is going to be 2.05 meters. Let's try another one. This time, to see the top of a building 1,000 feet away. Whew, you're far away. Here's 1,000 feet. You look up at an angle of you look up at a 24-degree angle of elevation. So that means from the horizontal, you look up 24 degrees. 24 degrees will go right about there. Okay, so 24 degrees. What is the height of the building? To see the top of the building, here's my building. And I know I have a right triangle here because buildings are perpendicular to the ground. So it looks like I'm trying to solve for this height. I've got an angle, a side, and I'm missing one side. So I mark my angle. I see x is the opposite side. 1,000 is the adjacent side. So that's tangent. Tangent of 24 degrees is going to equal x over 1,000. Multiply both sides by 1,000. And we're left with x equals 1,000 times the tangent of 24, which will be 445.23 feet. That building is pretty tall. Okay, one more. From the top of a lighthouse, 210 feet tall. So here's my lighthouse. Beautiful. So this is 210 feet tall. The angle of depression of a boat is 27 degrees. So here you're standing right at the top. So from that horizontal, the angle of depression, so here's my horizontal. Your eyeball, you're looking down 27 degrees at an angle of 27 degrees. We'll just extend that. So this is 27 degrees. Find the distance from the boat to the foot of the lighthouse. So we know this is 210. I'm going to just draw this side length. Let's choose a different color. Green. So here's your eyeball. Here's that height. And then here's my angle of depression. And I know my boat is going to be, it's going to be right down here. Let's just draw a lovely boat. Okay, so now we want to know what is going to be this distance right here. How far are we traveling? Or how far away is the boat? I could also draw my triangle like this. No, I'm just going to confuse you all. Oops. We'll connect it here. Okay, now I could also draw my boat like this. And I would know if these are parallel lines, this angle is also 27 degrees right here. So I'm gonna redraw this picture so it's a little less confusing without my lighthouse. So here's my lighthouse. My angle of depression is 27 degrees. So that means I'm looking out 27 degrees. And then I want to know the distance to that boat. Right? Now I'm getting myself confused, I'm sorry. We're going to have to draw 2 triangles. So here's 27 degrees. And here, this is parallel lines. These are parallel lines, so this will be 27 degrees. Okay, now we know this is 210, so I can look at either right triangle. I've got a missing angle, or I've got an angle, a side, and a missing length, because we're trying to find the distance from the base of the lighthouse to the foot of the boat. So this is going to be my angle. I've got opposite and I have adjacent, so it's going to be tangent of 27 is going to equal, let's see, 210 over x. Solve that is going to be x equals 210 over the tangent of 27. Solve and you get x equals 107.00 feet. Whew, sorry that one was so crazy. So again, when you're doing angle of depression, you need to draw the horizontal from your eyeball, and then it's going to be the angle looking down. Then, if you need to look at your triangle from the bottom here, you know you have parallel lines, so the angle of elevation is going to be the same as the angle of depression. So you can mark that down here. So that concludes our lesson. You can complete the handout that was given to you on last Wednesday when you had to complete the front. You now can complete the back. It's titled 12.2 Day 1, or just 12.2.